Welcome back. It is Manuary January. Yep. Haven't shaved all year, that's right. Haven't seen y'all all year, but here we are. Alright, well anyways. So yeah, we did the warm-up. You described something mathematical that happened over the break, and now we are doing these notes on simplifying radicals. Now, this unit is going to be on right triangles, trigonometry, Pythagorean theorem, and one basic thing you got to know is how to reduce a radical. Okay, so we're going to start on this. When we talk about squares, usually you think of the shape, right? When you think of squares, you might think of Mr. G. Okay, I ain't no square, right? So squares can also be numbers. Okay, so y'all remember how to find the area of a square? You multiply the two sides, you get a number, right? So if I square a number, that gives me a square number. So what squared is 4? What times what is 4? 2, right? So 2 squared is 4. Now this is basic. We're going to get past that. Okay, 9 is also a square number because 3 squared, right? Square number is a squared number. So 16, this is really easy, right? So you see the pattern? Fill it all in real quick. All these numbers, I would like for you to be able to just recognize are square numbers. You should be like 36, duh, that's 6 squared, right? 100, that's 10 squared. Like, it'd be nice for you to look over these, understand that they are square numbers, which means they can be square rooted and give you a whole number. So square root of 4 is, and working backwards here, square root of 9 is 3. Same idea. So fill that out real quick, please. Square numbers can be square rooted to give you a whole number. That's the gist of this top part. So now we need to talk about simplifying radicals. How many of you, if I gave you the square root of 50 and asked you what does that equal, how many of y'all would just type it in and give me a decimal? It's kind of what we're used to, but I'm telling you that's not what we're doing on this unit. I don't want you to just give me decimals. I'm going to show you the way to do a factor tree. Has anybody done a factor tree before? You break it down into what are called prime factors. So let's talk about this word prime. What does prime mean? I ain't talking about Amazon. I'm talking about what is a prime number. You can't what? Not multiply, but you can't divide it by any other number besides that number. Okay? So prime numbers, what's an example of a prime number that can't be broken down anymore? 2. What else? 5. 3. What else? 9 can be broken down into 3 times 3. Okay? 1 is actually not prime. We can talk about that later, but what about what do you think about 51? What, real quick, do you think 51 is prime? You would think, but 51 is divisible by 3. 3 times 17, right? What about 91? '91 actually is not prime. It can be broken down by 7. Okay, so anyways, but if it for sure cannot be divided by any other number besides itself and 1, okay, that's a prime number. 93 is divisible by 3. Well, anyways, so now, how many of y'all want to be bored to death by me reading this to you? Nobody. So instead of reading it to you, I'll let you read it if you want, but I'm going to show you how it's done. Okay. So look at this. Example 1 is the square root of 50. So here's what we do. We need to do a factor tree. Now I always thought it's weird to call it a factor tree because it's going down. Those are more like roots, which actually would make more sense because it's a square root with roots. But anyways, this factor tree, what I did not read that you do want to know is that you always want to divide by the smallest prime factor, which is always starting with 2. So here's the question. Is everyone looking up here, right? Does 2 go into 50? Yes. 2 times what? Okay, so I can break down 50 into 2 times 25. And when I break it down, you with me? I want you to cross out what you just broke down. 50 is gone now. Okay? Now, again, does 2 go into 2, well, okay, that's prime. So does 2 go into 25? Not 2. Does 3 go into 25? No. So now I try the next biggest one, which is not 4. It's 5. Does 5 go into 25? It does. 5 times 5. And again, because I broke down 25, it's gone. Do 5s break down? No, because they are what? Prime. That's the word, right? So, prime. Now, so there's 3 prime factors of 50. 2 times 5 times 5. Okay? Now, I know y'all like stories, so I'm going to tell you a story. Story time with Mr. G. Y'all ready? This is a good story, okay? There's so much drama. It's great. It's great. Ready? So check it out. Over the break, there was this party. It was such a cool party, people said it was radical. Okay? It was a radical party. And you know what? All the coolest kids were there. In fact, all the prime people were there. All right? So we got 2, 5, and 5. They were at this party. And just like any dramatic movie, there's 2 numbers that see from across the room, their eyes meet, and they're like, we're so alike, we're going to become a couple. Do we have any couples here that are exactly the same? The 5 and the 5. Aw, OMG, cute, etc. Right? So, we have a couple. Now, couples, when they're dating, they like to say they're going out sometimes. So, here's the deal. Even though the 2, 5, and 5 were inside, now they're going to be going out. The 5 and the 5 are going to go outside of the party, right? They're like, let's get out of here. This place is dumb, all right? But here's the deal. This is where it gets real sad, okay? Now, you ever want to be really serious, okay? When they step out into the front yard, one of them steps into a bear trap and gets sliced in half and doesn't make it. It's so sad. It's so sad. So here's the deal. When you have a couple, one of them is gone. It's so sad, okay? It just happened to be bear traps. Don't ask why. It is what it is. Now, here's the deal. We said that the couple's going out, so what am I going to put outside over here to the left? 5. Not 2 5s, not 10, not 25, just the number 5, okay? Now, here's the deal. Once all the couples leave, even though they don't make it through the... Okay, even though the couples leave, what's left over are what we call the loners. Do I have any loners left over? 2. 2 are still inside the radical party alone. So, what did I do? I made a factor tree. I found my couples. Couples go out. Loners stay in. You can do it without a story, but story helps to remember sometimes. So here's the deal. The only way this gets harder is what if there's more than one loner, or what if there's more than one couple? The answer is always going to be multiply. The answer is always what? Multiply. So when we get to the next 2 problems, and there's more than one loner, more than one couple, we're going to multiply. Okay? Multiply. So let's do example 2. Okay? Is everyone looking up here? Because if you're not, I don't have to teach it to you one-on-one. I want you to focus. So, everybody, on example 2, we always start with what? What do we break it down by first? 2, right? Does 2 go into 24? 2 times what? 12. 24 is gone. Does 2 go into 12 now? 2 times what? 6, yeah. Does 2 go into 6? 2 times 3. Okay. Now, I keep breaking it down, right, on example 2. So I got 4 prime factors, 2, 2, 2, and 3. Now, do I have any cute couples here? One pair of 2? Bless you. The 2 and the 3 are not a couple, right? They're not the same, so they're actually 2 separate loners. Okay? Now, again, tragedy. Goodbye. So, radical party, what goes out? The 2, the circled 2 goes out. And if I have 2 loners, 2 and 3, it's not 5 because we're going to multiply, right? 2 times 3 gives me 6. That's it. No. So, example 3, 180 is even because it ends with a 0. So 2 times what? 90. and then that 180 goes away. 90 is even, so 2 times 45. Now, does 2 go into 45? Okay, 45 is odd. 2 does not go into it. So the next one you need to try is 3. Does 3 go into 45? If you did not know, how could you tell 45 divided by 3, and it actually does give you a whole number? So what is it? 3 times what? 3 times 15 is 45, okay? Now you could do that in your calculator, 45 divided by 3, okay? Now, 15, what does 15 break down into? What do you think? 2 doesn't go into it. Does 3 go into 15? 3 times 5, okay? Now, do I have any pairs here? Pair of 2 and pair of 3. And they both fall into a laser bear trap. It's crazy. All right. So once again, radical house. What goes out? The 2 and the 3. Again, what do I do with the two numbers? Multiply. 2 times 3 is 6. And my loner left over is 5. So again, you break it down, you circle pairs, pairs out, loners in. Okay? Now, 2 more examples before I let you try some on your own. If you go to the next page, does anyone still need this? Okay, next page. So, 1260, is it even? So 2 times what? 630, okay? 630. Okay, 630 is also even, so 2 times 315. Now, is that even? Ends in a 5, so it's not even. So does 3 go into 315? If it does, what is it? 3 times what? Three times 105. Okay, now, does 3 go into 105? You can try by dividing it, but it gives you a whole number. 3 times what? 3 times what? 35. 3 times 35 is 105. Okay. And then, does 3 go into 35? Does 5? 5 times 7. Okay. Now, do I have any pairs? Pair 2, pair 3. Don't forget tragedy strikes. Triple bear trap. Now, I got my square root sign. What goes out? 2. The 2 and the 3 multiply 6. And the loners are 5 and 7. Once again, we're going to multiply. 5 times 7, 35. So hold on. So this week, when we do, y'all remember doing Pythagorean theorem? And it has square roots, and usually you would just type it in the calculator. Now, we're going to be reducing radicals when we do those Pythagorean theorem problems, okay? Okay, last one we're doing together, okay? So, what's weird about this next one? Please focus. What's weird about this one? Not that it's reversed, but what? It's not done. It's actually not done. There's just something. There's an extra number out front, right? Like this 76, we can still break it down, but see how there's a number outside already? So that's called a coefficient, right? That means there's already, it's kind of like a pair already went out, but we still need to get more pairs out, okay? So here's my suggestion. If there's already a number outside, a lot of people forget about it. I don't want you to forget about the number outside. So circle it. Think about, hey, this is a pair that's already outside. 5's already out. And now I'm going to start breaking this 76 down. It's even, so 2 times what? Not 32. No. 38. Okay. 2 times 38. And 76 goes away. 38 is even, so 2 times, and I'll help you on this if you don't know it, but close-ish, 19, okay? Now, 19, is that prime or nah? It actually is prime. Nothing goes into 19. So, are there any pairs here? The pair of 2? Tragedy. Now, here's how people do this wrong. They say, hey, look, there's a 2 and a 19, and I'm done. Wrong. That 5 matters, right? So if the 5 is already out, and then the 2 goes out, 5 and 2 multiply. So yeah, you do get 10 square root of 19. Say what? Okay. So do you see the idea? 5 is already out, 2 went out, 10. Okay? And then the 19 stays there as a loner. Now, I want you to try these 6 on your own. I really want you to try them, okay, because there's some of the stuff that we haven't talked about yet. I want you to see how it might get weird, and I'll tell you how it's supposed to look, okay? So let's go ahead and work on that. Okay, on number 1, we're going to do these a little bit quickly because of time, but did you get 3 times 9 and then 3 times 3? Okay, so you have 1 pair of 3s and a loner 3, so you'll have 3 square root of 3. On number 2, again, 2 times, and then 24, 2 times 12, 2 times 6, 2 times 3. It's a lot of 2's, okay? But did you circle your pairs, right? So pair of 2, pair another 2, and again, tragedy, tragedy. So 2 times 2 is 4, square root sign, the loner is 3. Now, on number 3, do you know what the square root of 36 is? Just, do you know what it is? It is 6. That's the first thing we did on these notes, is that all the square numbers have square roots. And you know the square root of 36 should be 6, right? Now, if you just wrote that, that's fine. But if you start doing the factor tree, this is what you'll notice. 2 times 18, 2 times 9, 3 times 3. And then you'd see there's 1 pair of 2, 1 pair of 3, and there's no loner. So if you get something with no loner, that means there's no square root. Okay? No loner, no square root. So now it's just 2 times 3, which is 6. So you can do it this way too, but hopefully you can just see the squares and know that the square root of a square is a whole number. That's it. Okay? 70 is 2 times 35. 35 is 5 times 7. Are there any pairs there? No pairs means you can't take anything out, so you can't actually change it, so it doesn't reduce. So everybody, if there's no pairs, you just rewrite it. That's it. No, 2, 5, and 7, no pairs, so just square root of 70 is square root of 70. Nothing changes. Now 5, this is tricky. Look at this. 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. What are my pairs here? What do you think? Now, so you see these 2 2's? Those can't be a pair. Here's why. This first 2 is already outside, right? So there's not 2 2's in my tree. So, yes, 27. So here's the deal. When there's a number already outside, I circle it by itself. And now, are there any pairs with what's left over? We already said, someone said, yeah, 3. So there's a pair of 3's. So the 2 is outside with the 3 that I just circled. 2 times 3 is 6. And the loner is actually 2 loners. 2 and 3 also is 6. So again, you can't circle something in your tree with something that's already outside. Okay, that's, I know they're next to each other, but they're not, you can't circle them. This 2? It's a coefficient, so this 2 right here that's circled was already outside. We did. That 2 was multiplied with that 3 to get that 6. Yeah. and then this 2 and this 3 were multiplied on the inside. Okay, last one. 3 times 25 is 75. 5 times 5 is 25. So again, these look like they're pairs, right? But this 3 is outside already. Like, it's not part of the tree in red, right? I'm talking to you, right? So does that make sense? Like, this 3 is already out there. So again, these can't be circled. This 3 is a loner, actually. There's only a pair of 5. So this pair 5 and this coefficient 3, those are multiplied together. It was already outside, and I was circled. 3 times 5 is 15, and my loner is 3. Okay? So I know those are tricky. That's why I'm showing you them. So make sure you be careful for those. Make sure you've done 1 through 6. Okay? Now we'll do the second part of these notes tomorrow, so make sure you don't lose them. Don't lose your warm-up sheet. You're going to turn those in Friday for an easy 100.